This series of videos is mostly vocabulary. In this video, we're going to see linear approximations. In the next video, we're going to see differentials. I have here the graph of a function f and a point identified on the graph a, f of a. And we can consider a tangent line to f at a. Let's call that line L. Now it's a tangent line, so we know the slope is equal to f prime at a. And since the tangent line contains the point a, f of a, we know the equation of the tangent line is y equals f of a, y minus f of a is equal to f prime of a times x minus a. If we decide to put everything on the same side of the equal sign, then we have that y is equal to f of a plus f prime of a times x minus a. This tangent line is the one we're calling L. Now, here's the thing about a tangent line. Close to the point of tangency, the tangent line approximates the curve. That is to say, if we were to zoom in enough, then it would be difficult to see the difference between the tangent line and the curve. And in fact, if we zoomed in so close, we wouldn't see a difference at all. Okay? That means that a tangent line is what we call a linear approximation. And the idea here is that when we're really close, f is approximately the tangent line. This is formalized by the following. The linear approximation, or the linearization of f at a, we have some things going on here. F prime of x is approximately L of x. That's what I set up here. And L of x is equal to f of a plus f prime of a times the quantity of x minus a. To be technical, the linearization is the one that says L of x is equal to all that stuff on the right. The linear approximation is the one that says that f of x is approximately all that stuff on the right. There, that should make it a little more clear. It's nothing more or less than the tangent line that you've been finding earlier in this course. So let's see what this is going to look like as far as an exercise in this lesson here. Find the linearization to f of x is equal to find the linearization to f of x equals the square root of x at x equals 1 and use it to approximate the square root of 1.1. Just imagine this is back in the day. You don't have a calculator. You need the square root of 1.1 or an approximation of it. Folks, the first thing we need is the derivative of f evaluated at 1. F prime of x is going to be 1 over 2 times the square root of x, which means that f prime of 1 is equal to 1/2. A is equal to 1. I need f of a. As it happens, f of 1, the square root of 1, is equal to 1. So, the linearization of x is equal to f of a is 1 plus f prime of a is 1/2 times x minus a, that's going to be x minus 1. This simplifies and we can say that L of x is equal to 1/2 x plus 1/2. That is the linearization to f of x at the point x equals 1. That's L of x. Now we're going to use it to approximate the square root of 1.1. Here, x is 1.1. So we're going to find L of 1.1. And that's going to be 1/2 of 1.1 plus 1/2. Now we're imagining we don't have a calculator. Well, you know that 1/2 of 11 is 5.5. So 1/2 of 1.1 is going to be 0.55. So 0.55 plus 0.5, there I get 1.05. And our statement is that that is approximately the square root of 1.1.